Okie doke. Oh, let me just sort my windows out here. There we are. Okay, so we've done our mathematical appendix, and now we're going to have a look at Solow with exogenous growth. And we're driving the growth through growth in labor productivity AL. So we have y equals ALL to 1 minus alpha k to the alpha, and we have AL dot over AL is G, so we've got constant growth rate. I'm going to write G, not GAL. If we like, we can let the labor force grow at N, and we know that growth in capital, and I'm not sure we've done this or not, I lost track, is Sy minus delta K. So in discrete time, we had KT plus 1 is Sy, let me see, Sy minus, yeah, KT plus 1 is KT plus Sy minus delta KT. Yeah. Or we could think of it as KT plus 1 minus KT equals Sy minus delta KT. And you can think the KT plus 1 minus KT for continuous time, we're replacing that by K dot. It's the extra K, right? The extra K over a short period of time, or the rate of growth. Well, yeah, not the rate, not the growth rate, but the extra K in a short period of time. If you compare to discrete time, think of it as KT plus 1 minus KT equals Sy minus delta K. Okay, so that's how we think about the shift from discrete time to continuous time. You need to be able to do both for this course. And it's great to be confident in both in general for economics. Okay, but how do we then characterize what happens in this model with growing AL? In general, we don't know whether we're on a balanced growth path or not. Okay, it could be if we start off with very little capital, and then we've got, compared to the level of AL, it could be that capital will grow very fast initially, and then will approach a balanced growth path. Okay, but as I explained on the math video, we're just going to focus on the balanced growth path and not look at transition paths so much at all in this course. So how do we find the balanced growth path? On a balanced growth path, we know that K dot over K, for instance, must be constant. Yeah, remember the definition of a balanced growth path. All the state variables have to grow at constant rates. So that's not K dot is constant, K dot over K must be constant. But from this, we know that K dot over K is S times Y over K minus delta. Hopefully this looks familiar if you looked at the math video. Delta is constant, S is constant, this is constant. That means that Y and K must be growing at equal rates. Y dot over Y must be the same as K dot over K. Okay, so what does that tell us? So from that, we can also say, well, I mean, there's a lot of different ways of thinking about this that will all get you to the same conclusion. So what have I done here? I've said Y over K is constant. Yeah, So another way of doing it, a bit different from what I've done here, I'm going to do it like I've done in the notes. So if y over k is constant, based on this definition of y, we know that y over k is ALL over k to the 1 minus alpha. Yep, I've just divided both sides by k. So if y over k is constant, then ALL over k must also be constant. And if ALL over k is constant, that means that the growth rate of this must be equal to the growth rate of this, which means that AL dot over AL plus L dot over L must be equal to K dot over K. Okay. So capital is growing at the sum of the growth rates of labor productivity and labor itself. Or, if you like, capital is growing at the growth rate of effective labor. We call this effective labor. The quantity of physical labor times its productivity is effective labor. Capital and effective labor grow at equal rates. And that rate, of course, is G plus N. So what is big Y dot over big Y? Big Y dot over big Y is K dot over K, which is G plus N. So total GDP grows at the growth rate of productivity plus the growth rate of the labor force. But what about little y dot over little y, where little y is y over L, so little y dot, yeah, we can write little y, okay, sorry, let's do it like this. Little y is y times L to the minus 1, okay, that's the same thing as y over L, right? So then little y dot over little y is big Y dot over big Y minus L dot over L, which, so it's G. Little y is, of course, GDP per capita. So GDP per capita grows at the growth rate of labor productivity. Okay? And capital per capita will also grow at this rate. Total capital, total GDP grow at this rate. Okay? On the balanced growth path, so in the long run, in the Solow model with exogenous technological progress. Okay, and here's a little, it's not really a test, but we'll call it a test of the Solow model with exogenous growth in labor productivity. In the left panel, we've got some real data and a constant trend growth rate, that is the dashed line. And we've got a massive loss of capital in around 1944, 1945 in the German economy due to the complete huge destruction at that time as the Nazis were defeated. In the right-hand panel, we've got the same dashed line with a constant trend growth rate of 2.3% a year, but with simulated GDP based on the Solow model with alpha 0.3, delta 0.1, S 0.2, which is the kind of standard numbers, and a massive capital shock divided by a factor of 30 at the end of year 24, at the end of 1944. Okay, so the Solow model does a pretty decent job to help us get our heads around the effect of shocks to capital in an economy. But what it doesn't do, which is what we talked about earlier, is explain the differences between countries. It doesn't explain the long run growth rate in any given country. It doesn't explain the difference between that country and another country, etc., etc. Okay. it doesn't explain a lot, to be honest. What it tells us fundamentally is that technology and productivity in an economy is key, but as it doesn't explain anything about what determines technology or productivity, that's really where it stops in terms of the long run. Okay. What's the Solow model good for? Well, among other things, dealing with the short to medium run, the effects of shocks, and so on. What drives growth? Exogenous technological progress. What drives growth in real economies? Well, we could say, if you like, endogenous technological progress, right? Okay, I think it's time to stop. Let me see. Yeah, and then there'll be a very short video on Ramsey, but I'm going to do that in a separate one.